Welcome to the sample lecture created for one of the assignment in the FDP on use of ICT in education for online and blended learning. This is a video created for the own classroom teaching. The subject is wireless communication and the topic is Introduction to Multiple Access Techniques, FDMA and TDMA. These are the learning objectives. At the end of the lecture, student will be able to, number one, explain the need for multiplexing in communication systems. Secondly, explain the basics of frequency division multiple access, that is FDMA, and explain the basics of time division multiple access, TDMA. This is the lecture plan. We'll recap the need for multiplexing. We'll visit to the introduction to FDMA, then TDMA, and at the end, we'll leave you with the review questions. This is a typical example taken from the fluorescent text to explain the need for multiplexing. We can easily see from the left figure and the right figure the distinction. We can see that in the left there is a one-to-one connection between each terminals, while the terminals shown to the left in the figure B are connected via common media to the terminal connected to the right hand side. So this clearly shows that with the use of the common mechanism, we can optimize constrained resources and also we can save the cost. I think that this you have already learned, and this diagram will help you to understand the basic concept again. Multiple access schemes are used to allow memory mobile users to share the finite radio spectrum, and we know that this is the scarce in nature. Sharing of the frequency spectrum is required to achieve the high capacity by the same frequency bands used. At the same time, we need to understand the trade-off that performance should not get degraded in any of the applications, like in voice communications, interference cases, maximum delay which has been allowed, bit error rate, while we try to make the number of users more and more. This is the basic diagram to show that how multiple access being done. We can see that base station is trying to communicate to this mobile stations. Various mobile stations may be located at the different places. We can see that it has got the forward link, it has got the reverse link, and base station is trying to make the individual connections to all these mobile users at its own. This is the first multiple access technique, which is known as a frequency division multiple access. We can see that there are two axes. One is the time axis and the second one is a frequency axis. We can define the FDMA as that usage of the subbands, that is the frequency axis is being subdivided with the small little bands, and each of these sub-band is being used by the individual users at the same time. Let us understand it clearly that say for example user number A is using this F0 centered frequency band, user number B is using this F1 centered frequency band, and so is with the user C. So we can see that time remains same for throughout and different frequencies being accessed by the different users at the same time. This is how it has been actually done. We know that all voice generated signals are between 0 to 4 kilohertz for the speech signals. However, the modulators which are being used for in each of them are supposed to be different. Say for example, this has been used at F1, this is at F2, this is at F3, and this is the resultant modulated signal. At the receiver part, when the signal comes, with the demultiplexing technique, we can see that the filter corrects the signals and then again they are being passed to the demodulator, so that again the signals are being converted back to the in-band signals. This is the another mechanism that is called the time division multiple access. So in contrast to the previous case, instead of frequency, now the time axis is being serrated. So at the time instant A is being used, at another time instance B is being used, at another time instance C is able to send the traffics, and then the process gets repeated. To understand it more clearly, let us see that this is the data traffic for the user A, B, C and D. This is a commutator bar that takes the data to the output. We can see easily that first of all commutator bar goes to A, and user A sends the data, then it is the turn for B, and then C, and then D. Depending upon that the slots allocated to the different users, this is being accessed. In the second frame also we can see that A, B, C, D are able to send the traffics. So as with the third slots. However, we see that as the user number B had only 3 packets to transmit, after 3 sessions that the slot for the user B remains vacant. Let us see the other part of this synchronous TDM process. We can see that data is coming now at the receiver part. Again the same sort of commutator bar is there. First of all, whatever the data in the time segment A comes, that goes to A, then B and C and D. So this is, we can see that how easily these things can happen. So this was the basic review intended for this sample exercise. These are the review questions that one can work out. Think about the answers to the following questions before coming to the class. You should think about the advantage of the multiple access schemes. Partially we have already discussed. Practical examples of the multiple access schemes. Again, one example we have discussed. You can think about many more. Advantages and disadvantages of FDMA, basic mechanism, we have already discussed. So in view of that, you can easily think about that what are the clear-cut distinctions afforded by the FDMA mechanism. The same with the time division multiple access. And lastly, this is the overall summary. This is what we saw in FDMA, that frequency axis being serrated. This is the TDMA mechanism in which the time axis being making serrations. The question is that just like a slice of a bread, are we able to make or devise some mechanisms in which the entire frequency bands and time axis are available to us? The question is this possible? If possible, then what is the mechanism? I hope that you have enjoyed this lecture, and next time when you come, you are there with the answers. Thank you.